All right, now let's say that we're told the velocity of an object is given by v of t is e to the t minus t, where t is measured in seconds. If the initial position of the object was 2 feet from the starting point, how many feet from the starting point will the object be at t equals 4 seconds? Well, folks, we know the rules. We know that if you have some sort of, I'll call it s. S is a very common letter we use for position. So let's say the position function, we know its derivative is velocity, and then its derivative is acceleration, right? So if you have acceleration and you take the antiderivative, you'll get velocity. And then you take the antiderivative and you get position, yes? So we should be able to toggle, like just go back and forth between these things, go derivatives left to right, go antiderivatives right to left, yes? So here, let me get rid of all this stuff. In a similar sense, then what we're given here is we're given the what? We're given the velocity, and then asked about the what? Position. So let's take the antiderivative of velocity and get our position function. So look, we have e to the t minus t. What is the antiderivative of e to the anything? Well, luckily it's just e to the anything. So the anything in this case happens to be a t, but that's fine. Minus, what's the antiderivative of t? Well, think about it. It's t to the first, right? So we're going to add 1 to the exponent, make it t squared, and then divide it by 2. Now, I encourage you to take what you see I wrote down right there and take its derivative super fast. If you take its derivative and you get this, cool, proceed forward. If you take the derivative of what you just wrote and you don't get that, press pause and double check it and see if you maybe missed a step, all right? And now we have this obligatory plus c. Now I always tell people this, whenever you're given some function and you're asked in some way or another to take its antiderivative, there's always going to be the obligatory plus c in the end, unless there's other information. If there's other information, then, and only then, can we get rid of the plus c nonsense. So we are told that the initial position is 2. What that means is that the function's position at time equals 0 is 2. So watch this. What that means is that if we pop in 0 for these t's, we should get a 2 over here. So let's try that. 2 equals e to the 0 minus 0 squared over 2 plus c, right? Well, e to the 0 is going to be 1, mind you. 0 squared over 2 is going to be 0, so I'll ignore that and get 2 equals 1 plus c, right? So if I subtract 1, what I discover now actually is that c is 1. So look at this. So look at that function up there at the top of the screen. I'm going to rewrite it like this. My position function at any time t is actually equal to e to the t minus t squared over 2 plus 1. So now that bad boy gets rid of that ugly c nonsense. And from there, now I can answer any follow-up question quite easily. So we're asked, for example, what is my position at time equals 4 seconds? I'd say, oh, that's pretty easy. You see, s of 4 is e to the 4th minus 4 squared over 2 plus 1. Well, let's pop in those numbers now. Let's see. That's going to give us e to the 4th. Now, e to the 4th doesn't really budge anywhere, I guess. Minus 4 squared is what? 16, right? 16 over 2 is 8, right? So now this is negative 8 plus 1. And ultimately, I guess, I can't really make that look much nicer than to say it's e to the 4th minus 7. And that right there is going to be my answer.